Hello everyone, so this is the number 19 on 2023 AMC 10A, okay? So it's a transformation problem, so I guess straightforward. So we have A, B as 2 points. We are transforming those to get the A prime and B prime. And we are told by the rotation center at A point. So it's not origin, okay? So this is the center at this point. So the difference between the coordinates of that rotation center, okay? So since we are dealing with some sort of like rotation, and if you look at the points X and like the A and B coordinates, they are kind of closer to each other. So which is why I'll draw a picture where I have a large, I guess, area to work on, so I can see how that looks like. So which is gonna be useful. And I just need only first quadrant, so which is why I'll draw everything on that region. So let's think about this is our coordinate plane, right? And then 1, 2, so I'll take the one is, let's say right here, and 2 is right there, and 1, 2, 3, 4, okay? And that would be 3 and 4. As you see, it's not really scale, but at least it does the job. So 1, 2 is gonna be something right here. So that's A. And 3, 3, so that's 3. So that should be something right there. Okay. And then when you transform these, you got A prime 3, 1. Okay, so let me try A 3, 1. So that should be this point. And then 4, 3. So this was 4, and this was 3. So it looks like we are gonna get this point. So it is really important for us to remember, like whenever you are trying to rotate a point on like another point, the distance between the original point, okay, so for example, the point A, and distance between the reflection, like the image, I would say, from the center of the rotation should be same. What I mean by, for example, if you take the, let's say this is the point of the rotation. So let's assume you have a straight line like this, and then if this is the point A, okay, and if you rotate in any direction, let's assume we are rotating this way, and then we are getting this A prime, right? So what I'm trying to say, this distance, so let's say this is O to A, and O to A prime should be same. What we are trying to do, we are taking the any point, in this case like A, rotating by a fixed point. Fixed point is called central rotation. So when you do so either this way or that way, so this between the center and the A is the same as center and A prime. This is important, but also when you take a look at the center could be right here, for example, but could be something right here. So because if you take this distance and then this distance, right, those two are going to be same, and then you can take the center right here. So this would be equal, so that should be equal to these two. But what is the common between those points? Like if you add a lot of points on this kind of line, you will see that any point on this line will have the equal distance from the A prime and A prime, A itself. So, and then this is actually the line that is perpendicular bisector of the points between A and A prime. So, which is why this is kind of a background, so I like to remind. But if you don't remember this one, so it's good to review the relation between A point and its image after transformation, okay, or after like rotation, whatever. So what I'm trying to say right here, when you rotate the point A by any point to get A prime, the the segment you connect with A and A prime, that should be perpendicular bisector to the the line that passed through the central rotation. Okay, so I hope that makes sense. So that is something we need to know because this is going to be useful in our problem. So what I'm trying to say, if you connect to like 2 points that we are given, so A and A prime, okay, so let's say you connect these two, and then connect these two, B and B prime. So my central rotation, we are not given, so that's the point S and T, maybe some fraction. So should be on the line that is perpendicular bisector A to A prime. So if you take the right in the middle of this line, so you should be getting something like this. So let me try to make it a bit better looking. Okay, something like this. We don't really know exactly, but that looks promising. And the same thing with the second line. So I should get a perpendicular bisector going through right in the middle of the second segments. Okay, so if you extend this one, so maybe I should do. If you do so, they will have some point intersection. So it doesn't look like nicer on my figure. That's why at the beginning I said it's good to draw a kind of larger figure, but at some point it will intersect. So that is the point actually, is the center of rotation. So let's see how that looks like. So we are given this is a perpendicular because that has to be on the perpendicular bisector line. And then this segment is the same as this segment, and this segment same as this one. So we know the slope of this line, we know the slope of this one, even though we are not given, but we can find those. So slope between A and A prime, so if I do this, okay, is basically 2 minus 1, which is 1, 1 minus 3, which is -2, 1 over -2, so I can just say 1 over -2. And if this has the slope of -2, the perpendicular bisector should have slope of the perpendicular bisector has to be 2 because the slope of the two perpendicular lines are negative reciprocal of each other. So they should be 2 for the slope of this one, which looks reasonable because it goes upward on like a positive slope. That makes sense. Why do I need this slope? Because I like to find the equation of this line. I like to find the equation of this line so I can solve that system to get the intersection, which will be my center. So that is something, you know, and I like to write the equation so I can use the slope intercept form. So that should be 2x mx plus b form. And to get b, I like to choose a point on this line, but we don't know that, right? So, but we can take the midpoint of A and A prime. So that would be the average of the x's. So 1 and 3 add up to 4. That's going to be 2 for the x coordinate. And then 2 plus 1 is 3. So that should be 3 over 2. So this point is the midpoint, 2 comma 3 half. Okay. So if you plug in this equation for x is 2, right? So that should be 4. So 4 plus something should be 3 half. So let's write that. So from this, so you get b as 3 half 1.5 minus 4, which is negative 2.5, negative 5.5 over 2, right? So the equation that we have for this perpendicular line to A prime is equal to 2x minus 5 over 2. Okay, so keep this in mind. And the second thing we are going to do is the same as the first one. So the slope between b and b prime, so is basically the slope between b and b prime is the difference of the y's, which is like 0, like 3 minus 3 is 0. So 0 divided by 3 minus -4 is just -1. That is 0, which is why we cannot really write the equation because we need to find the perpendicular the slope of the perpendicular line, which is going to be this one, which is clear because if the slope is 0, which means this is horizontal, or we can see it, the y values are equal, which means we don't need to write the equation at all. So the equation of the perpendicular is just vertical line. So it wasn't always perpendicular based on my drawing, but it is the case because this has to be horizontal since they have the same y's. That means this is going to be vertical. So this line, the vertical line, is actually passing through right in the middle of B and B prime. So if you take a look at the midpoint of B and B prime, so I'm going to write midpoint of B prime. So that should be 3 plus 4, which is 7 over 2, because we take the average, and 3 plus 3 over 2, which is also 3. And the midpoint of B to B prime is this point. So x coordinate is 7/2, so which means this line is equal to x equals 7/2. And what we are trying to do is this intersection. So we know the equation of this line. So let me write this, was 2x minus 5 over 2, right? And then there is a line going through this way that is x equals 7. So if you plug this into this equation, so we are going to find the y value. So let's do this right here. So the y value of this intersection is going to be 2 times 5, 7 over 2, minus 5 over 2. That's 14 minus 5, which is 9 over 2. So the y is 4.5. So the x coordinate was like 3.5, right? So the y coordinate is 4.5. So we are looking for the positive difference between the coordinates. So that is actually just 1. So again, it is a bit complicated looking. So if you do have issues with this problem, I guess you have to review the Solving equation as basics background, and also relation between the perpendicular, the rotation point before the like rotation and after rotation, which is like we just said, the perpendicular bisector should be the line that passed through the center of rotation. So if you are not convinced with that statement, please take a moment and think about it, maybe read something about it. So that is the whole point of this problem, I would say. So I hope that makes sense. I'll see you in the next video.